Hey there, Seahawks, it's Miss Adams, and in this video, we're going to continue working with the normal curve, but we're going to work on finding area between values. All right, so area in between two values. If you choose to do this using z-scores and the table method, you will find two separate z-scores, then their corresponding probabilities from within the table, and then subtract those probabilities to find the difference between the area under the curve. If you use the calculator, you can set the lower and upper limits to your range of values that you want to be in between. All right, our first example, a set of laptop prices are normally distributed with a mean of $750 and a standard deviation of $60. What proportion of laptop prices are between $624 and $768? All right, so we're going to, in the calculator, go to normal CDF. My lower bound will be the lower price point, $624. My upper bound will be the higher price point, $768. My mean is $750, and my standard deviation of $60. All right, so in my calculator, what I'm going to do is go to my distributions menu by doing second vars. I'm going to go down to normal CDF, hit enter. I'm going to put my lower bound of $624, my upper bound of $768, my mean of $750, and my standard deviation at $60. Hit paste, hit enter again, and we get our answer, which is 0.600004. Okay, our next problem. What proportion of values are shaded? So they gave us this normal curve. It's labeled. They have some of it already shaded for us. So I know I'm going to be using a normal CDF since I'm working with a normal curve. My lower bound, it looks like it's happening at 80. My upper bound is at 120. My mean looks like it's at 100. Okay, remember your mean is going to be right there in the center of your, like right below the highest point of your normal curve. If you come down, that value is your mean. And then each time it goes over, it's counting by 20. So my standard deviation is 20. So I'm going to put that in the calculator. Distributions menu, second vars, normal CDF. My lower bound is going to be 80. My upper bound is going to be 120. My mean is 100, and my standard deviation is 20. Paste, enter, and we get 0.6827, or 68.27%. All right, for our next problem, we have find the area under a normal curve that lies between a z-score of negative 1.5 and a z-score of 2. All right, so they already told me that I have the z-scores. So I know I'm going to use a normal CDF because z-scores, z-values, all of that stuff comes from a normal model. My lower bound will be my negative 1.5. My upper bound will be 2. When I'm working with z-scores, my mean is always 0. And my standard deviation is always 1. All right, so I'm going to put this in my calculator. I'm going to go to second vars, which is the distributions menu. I'm going to go down to normal CDF. My lower bound is going to be negative 1.5. My upper bound is going to be 2. My mean is 0. And my standard deviation is 1. Hit paste, hit enter again, and we get 0.91044. So 0.9104 or 91.04%. All right, this problem. The mean weight of adult American men is 180 pounds with a standard deviation of 25 pounds. The weights are normally distributed. What percent of adult American men have weights between 130 pounds and 205 pounds? Okay, so I'm going to do a normal CDF. They told me it was normally distributed. My lower bound will be 130, my upper bound will be 205, my mean will be 180, and my standard deviation will be 25. All right, when I do this in the calculator, I'm going to go to second vars, my distribution menu, normal CDF, lower bound 130, upper bound 205, mean 180, the standard deviation 25. Paste, enter, and we get 0.8186 or 81.86%. So you can see that this is really saving a lot of time, because before we had to take each of the two values, find the z-score, find the probabilities from the table in the z-score chart, subtract those to find the difference between. So using this technology really helps us a lot. All right, go Seahawks.